Hello everyone, welcome to Mathematics with Shahab Yaqub. So in this particular channel, you find a lot of videos. Basically, they relate to past paper solution or topical past papers or the concept behind it. So what's the agenda for today? That is going over this particular paper 5, that is probability and stats 1, popularly known as S1. This is the May-June 2024 paper and this is the first variant. Now this is a walk-through video, which means the solution is already there. I'll go over the solution. It will save time at your end so that you can comfortably try it out and go over the solution very quickly. So the first question is about mean and standard deviation. The question says a summary of 20 values of x gives the following result. The result is in the assumed mean format. That means from each value of x, 30 was subtracted and sum of x was taken. Over here, this is summation of x square. That means from each value of x, 30 was subtracted, each value was squared, and then we added up. Similarly, a summary of another 25 values of x is given. First part, find the mean of all the 45 values. 20 plus 25 is 45. So this is the summation of these values. This is the summation of these values. Let's use the symbol y for this, add it up, you get 909. We calculate W bar, sigma W. I have denoted the symbol for the overall sum. W bar is the overall average. That comes out to be 20.2. 30 was subtracted, we add it up, we get the answer as 50.2. What about the standard deviation? First of all, sigma y square, the blue one, sigma y square, the green one, that is added up, we get this thing. We already know sigma w from before, we know n is 45. We find the standard deviation for this data. Definitely you need a calculator and work in at least 4 significant figures. 4 significant figures is good enough. You get this answer since it's asking for standard deviation, therefore we take the square root. So basically ST square is variance. I don't put the square root at the beginning. I wait till the very end, then I apply the square root. This final answer is given to 3SF. Question number 2. Now let me label it. So what is this question all about? So now this question is about normal distribution. So let's get started with this. It says the lengths of tails of adult raccoons, that's kind of an animal, of a certain species are normally distributed with mean 28 and standard deviation 3.3. First part, find the probability. That means the 7 rules. Remember what is being taught in class and in different lectures. Find the probability that a randomly chosen raccoon of this species has a tail length between such and such. First of all, identify the distribution. X follows normal distribution. There goes the mean, there goes the variance. X lies between 23 and 35. Standardize, work in 4SF, work in 4SF. And then one z value is negative, one z value is positive. So the way that I've taught, this is rule number 7. That means when one z value is negative, one z value is positive. Yes, some people can draw a diagram and do all the necessary working. That's their choice. What I do is that based upon the diagram, I have formed these rules. Discard the negative value, read the table for this value, and this is the probability. Read the table for this value, this is the probability. Add the probability, subtract 1, you get this answer. Now keep in mind, this is the z value. The table is for 3 decimal places. So basically I read it for negative 1.52 and I read it for 2.12. It's written to 3 decimal places, but the reading will be up to 3 decimal places. So 1, 2, 3. So that is the thing that is to be done. So kind of a mix up between the decimal places and the probability. The probability is given to 4 decimal places or maybe 4 significant figures. So that's the final answer, 3SF. And the z value, this is just a reminder, this is 1 dp, this is 2 dp, and the last column, the add column, that is 3 dp. So this is 1, 2, 3, that is perfectly all good, all right. So let's move on. It says the masses of adult raccoons of this species. So now there is a different type. They have a mean 8.5, standard deviation sigma. 75% of adult raccoons have a mass greater than 7.6. That means there is a value greater than that is 75%. Now, when this probability is greater than is 50% or above, and there is a greater sign, that means the z value is negative. So this question I could have done without the diagram also. These are the two golden rules that I have taught. What are those rules? Make sure the probability is at least 50%. If z has a lesser sign, z value is positive. So z lesser means positive, z greater means negative. So therefore, this is the negative. Standardize, equate with this one. Remember, equate this with this. You equate the z with this. You cannot equate z with the probability. And that is something that the examiner has expressed his concern or her concern a lot of times, that that's a mistake people make. How can you equate a z value to a p value? That's not possible. Yes, based upon z, you can find p. Based upon p, you can find z, but you cannot equate them. So basically, this is what you do, and look at the working over here. That is a necessity. Also, sigma comes out to be positive. So this was negative. Even if you don't want to think, you should think that in back solving, this z value was negative. Negative, negative cancels. You get this answer. So two questions are done. The third one, which I personally find boring to draw because the other things are so interesting, but still what you need to do, you need to do. So this is frequency distribution. Let's get started with this one. Now it says the heights in centimeters of 200 adults in this particular town. They have all these weird names for these towns, are summarized in the following table. There is height, there is frequency, it's ending at 150, starting with 150, ending in 160, starting with 160. That means this is the class boundaries. When it's the class boundary, upper class boundary minus lower class boundary gives you the class width. 150 minus 130 is 20, 160 minus 150 is 10, and so on. And then since the class widths are unequal, we apply the concept of frequency density. What is the definition of frequency density? That is frequency of a particular class divided by class width. So now 16 over 20, 0.8, 32 over 10, 3.2, 76 over 10, 7.6, 64 over 5, 12.8, and this is 12 over 20, that's 0.6. That means the maximum value is 12.8. It goes on the vertical axis, and this goes on the horizontal axis. So before I get started, what I'll do is that I'll count the squares. So this is 1, and this is 2 big square, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's starting from 1 to 30. Of course, the horizontal axis, I won't start from 0. I would draw a squiggly wiggly. So when I would draw a squiggly wiggly, basically that's a compression line, and this is only possible, this is only allowed on x-axis, on the horizontal axis. Y-axis, keep in mind, that can never be compressed, because that will give you a false idea about the height. So now over here, look how I have done this. I have drawn this jagged line, the line of compression. I'm starting with 130. Now, when you look at the mark scheme, what they have done is that they have started over here. So, I mean, that's their choice. I took this to the maximum, started with 130, 140, 150, all the way. I'm exactly ending the graph at 195. So first thing, first be comfortable. Now, sometimes when something is too basic, too easy, too boring, that's where you make a mistake. So be very, very careful, very, very careful. Okay, and what about the y-axis? So I'm taking this as 2 units because I can go all the way till 14. I just have to go till 12.8. And then the rest of the story is pretty simple. Frequency density on the vertical axis, height, which is the class boundaries on the horizontal axis. I have drawn 5 bars, pretty simple. Now, the interquartile range is R. Show that R is not greater than 15. So what I have done is that I have copied this thing over here. And 1/4 of 200 is 50. So the cumulative frequency 50, where does it lie? 16 plus 32 is 48. 48 plus 76, that means the 50th value, T50, lies over here. That means the lower quartile, let me write it over here, the lower quartile lies in this interval 160 to 170. 3/4 of 200 is 150, cumulative frequency, I'm looking for the upper quartile. So now over here, let's back solve. This is 12, and if I subtract 64, 74, 76, that means this would be something like the 124th value or something, or 126th value or something. That means the 150th value would be lying in this interval. So lower quartile lies in this interval, upper quartile lies in this interval. And what are the options? If I need the maximum value of IQR, I take upper quartile to be the maximum, lower quartile to be the minimum. So let me again illustrate this. IQR max is obtained when upper quartile is the greatest and lower quartile is the smallest. And IQR minimum will be obtained when upper quartile is the smallest and lower quartile is the greatest. The concept of upper bound, lower bound, least value, greatest value in O-level math. So I took this value, that is 175. I mistakenly wrote this thing as 170. Let me correct myself. So green marker from here, this is 175. And I subtracted 160. This answer comes out to be 15, and that is the maximum value. It cannot be greater than 15. And the minimum value in this case is coming out to be 0. This is basically not asked for, but some other time if they ask for it, you know exactly what to do. So now this thing is done, and what is this question about? I think this is about basic probability. So probability, that's the name of the paper, probability and statistics. So this is like high level probability. Now it says a game is played for 2 players, is played using a fair 4-sided dice with sides numbered 1, 2, 3 and 4. One turn consists of throwing the dice repeatedly up to a maximum of 3 times. So it's a max of 3 times. When a 4 is obtained, no further throws are made during that turn. So if you get a 4, no further turns are made. A player who obtains a 4 in their turn scores 1 point. Now these are the rules and regulation. So rules and regulation that you have to refer to. Show that the probability that the player obtains a 4 in one turn is this thing. Now obtaining a 4 is 1 out of 4. Not obtaining a 4 is 3 out of 4. It's a fair die. That means all these numbers have an equal chance. That is what we mean by the word fair. Getting a 4 in the first attempt, that's 1/4. Getting a 4 in the second attempt, this is like geometric probability distribution. You have to get success, but you are limited by the number of times. Getting a 4 in the second attempt, that's a failure in the first, success in the second. 3/4 into 1/4, that's 3/16. Getting a 4 in the third attempt, that's the maximum. So that's a failure, success, that comes out to be 9/64. Now what I have done is that, since I have to add it up, isn't this a good idea to have the same denominator in all of them? So 9/64 is the standard. 3/16, multiply and divide by 4. So 3 into 4 is 12. 16 into 4 is 64. This is 1/4. So 1/4 into 16/16, denominator is 64, numerator is 16. So 16 plus 12 plus 9, if I add the numerators, the denominator remains the same. This comes out to be 37/64, and the first answer is given, so that you gain confidence and you gain certainty that yes, I have done it correctly. So that is a support from the examiner. The next one, there are 2 players. Let me call one of them X and the other one Y. Again, the names are no comments. X and Y play this game. Find the probability neither X nor Y score any point in the first 2 turns. So scoring 1 point, the probability is 37/64. Scoring no point is 1 minus 37/64, which is 27/64. So first, this person X throws the dice, does not score anything. This person Y throws the dice, does not score anything. We are talking about 2 turns. Then X throws the dice, does not score anything. Y throws the dice, does not score anything. So this is basically 27 over 64 raised to power of 4, and that's the answer. Now I'll take you to the mark scheme, and I'll just give you the idea that the mark scheme does not, and it's not their responsibility to explain you everything in great detail. And there it is somewhere over here. Okay, so I think this is the one. The first part, they have explained it like this, but not in much detail. There are 2 methods of doing it. I have done this particular method. So that is to my liking. That is how I have done. And then there is this thing. So basically the 3-part thing, they have written in 1 part. Not everybody will be able to understand it. That is why the guidance comes into play, that you need proper guidance in order to understand it thoroughly. There is also the 3rd method, so I'm not very sure. I'm good and happy with this method. I like easy method. I want to convey it in easy style. Now over here, the 4B, there are 2 methods over here. And this is the one that I have used, and that is this, that 1 minus 37 over 64 raised to power of 4. Now this is the final stage that you're looking for. But how do you get this? It's not their responsibility to explain it. That is why you have to understand it from the right source. So now coming back to this one, that's the IQR thing. So now this thing is done. Now comes the last part, which says Zeno and Yao, X and Y, each have 3 turns. Find the probability X scores 2 more points than Yao. That means, what if Yao scores 1, Y scores 1, X scores 3. There is a difference of 2 points. X scores 2 points more than Y. Y scores a 0, X scores a 2. So first you list the possibilities, and then you calculate the probabilities. So first, possibilities. What are the possibilities that this scenario is possible? And then go ahead and calculate the probabilities. So now over here, this is binomial. Out of 3, X is scoring 3. So 3C3, success raised to power of 3. And this is 0, 27 over 64 raised to power of 0. And then the next one. Y scores a 1, 3C1, success raised to power of 1, failure raised to power of 0. And means multiply, and this is the small answer that you get. Similarly over here, X scores 2, 3C2, success probability raised to power of 2, failure probability raised to power of 1. And Y scores a 0, 3C0, 37 over 64. First I focus on the probability of success raised to power of 0, failure raised to power of 3. Now again have a look at how they have done. So that's right over here, and they have done this thing this way. Again, it's not clear how they have achieved this result. They have simply written this thing without giving you any idea. Correct probability for one identified scenario, except unsimplified, add values of 2 correct scenarios, identification may be implied, correct unsimplified expression, condone omission of 3, values may not be probabilities, and so on. So do not go into all these details. Just focus on understanding the concept thoroughly and then applying it. Yes, do double check your answers from the mark scheme, but sometimes the method is not up to your level. Now question number 5, what is this? Question number 5, I think it's binomial. So let me write over here, this is binomial probability distribution. Now it says in a certain area in the Arctic, the probability that it snows on any given day is 0.7, independent of all other days. So probability of success is 0.7, probability of failure is 0.3. Find the probability in a week, 7 days. The number of trials is 7. It snows on at least 5 days. X follows a binomial distribution, 7, 0.7, greater than or equal to 5, that is 5, that is 6, that is 7. calculate individual probabilities, add it up, put it everything in the calculator. This is the answer that you get. A week in which it snows on at least 5 days out of 7 is called a white week. So at least 5 days, this white week probability is from the top. Find the probability in 3 randomly chosen weeks, at least one is a white week. So now this is another binomial distribution. This time the number of trials is this 3. And answer of part 1, that is the probability of white week, that is the probability of success. So y is greater than or equal to 1, at least 1, 1 minus probability of 0, 1 minus 3c 0, success raised to power of 0, failure raised to power of 3. And that is the answer that you obtain. Now it says in a different area, the probability that the week is white is 0.8. So now this is a different probability. Use a suitable approximation. That means normal approximation to binomial. Find the probability in 60 randomly chosen weeks, fewer than 47 a white week. So first of all, I'll write W follows a binomial distribution. 60 is the number of trials. That's the total number of weeks. Probability of success is given. So I have over here, this is N, this is P, this is Q. I calculate NP, I calculate NQ, I calculate NPQ. So now for justification, which I should write even though the examiner is asking for it or not. That is since NP is greater than 5 and NQ is greater than 5, therefore W now follows a normal distribution, and this is the mean and this is the variance that goes in the bracket. That thing is done. Now don't forget continuity correction. Whenever we change from binomial to normal in S1, and later on in S2 we would be studying Poisson distribution and other things, CLT, central limit theorem and so on. So such things would come into play. Maybe they would, maybe they won't. Let's see, and let's wait until S2. So now lesser than 47 weeks, 47 cannot be used because this is from binomial discrete probability distribution. The lower bound is 46.5, upper bound is 47.5. We are going in this direction. Since it's not inclusive, we choose the blue line because it's not including 47. So probability W is lesser than 46.5, probability Z is lesser than 46.5 minus 48 divided by square root of 9.6. We get this Z value. Z lesser than a negative value, symmetry, Z greater than a positive value. There is no need of drawing a diagram. Therefore, this is like rule number 2. Whenever you have to find the probability for greater, we find the probability for the lesser value, and then we get this answer. So therefore, this is 1 minus, let me remove this phi over here. This is the answer that you obtain from the Z table, and this is the final answer that you get. Question number 6. Again, a probability question. So now this is probability again. So I think there is too much of probability in this one. It says Harry has 3 coins. One coin is biased. Probability of obtaining a head is 1/3. Head 1/3, tail 2/3. So let me just highlight this thing. So that is Harry over here, and he has 3 coins. The first coin is this thing, biased, and like this. Head and 1/3. The next one is the second coin. That's also biased, and the probability of obtaining a head is 1/4. So head is 1/4, tail is 3/4. Then the third one. The third coin is also biased. Too much biasness in this. And the probability of obtaining a head is 1/5. So now this is 1/5 and 4/5. Now this is comparatively easier as compared to that X and Y and the 4-sided die. This is comparatively easier. Now it says draw up the probability distribution table for X. What is X? Harry throws 3 coins. X is the number of heads that he obtained. So the person could obtain 0 head, 1 head, 2 head, 3 head. Let me calculate the easiest one, 0 head. That means all these 3 are tails. So what I'll do, I'll take this probability 2/3, 3/4, 4/5. 2/3, 3/4, 4/5. I get this answer. The extreme, that is all 3 are heads. That is head, head, and head. So that is 1/3, 1/4, 1/5. That is also 1/60. So you are getting these values. So you get 0 head, that is 24 over 60. You get 3 head, that is 1 over 60. Now it's your choice. Choose, just do the working for one, not for both. For example, I have done the working for 2 heads. So this is head, head, tail, head, tail, head, tail, head, head. So this is head, head, and then a tail. And then head, and then tail, and then head. And then a tail, and a head, and a head. So all this thing is written over here. This comes out to be 9 over 60. So now I have these three. That is, I think, 24 over 60, 1 over 60, 9 over 60. I add this up, this plus this plus this. And then I subtract from 1. What do I get? I get 26 over 60. That is for 1 head. So that is the last step that I've done. I have not done the calculation again. Why waste time? And naturally, of course, you should draw a table right over here, which I think I forgot. So let me just do it right now. So this is X, this is probability 0, 1, 2, and 3. 3 head is 1 over 60. 2 head is 9 over 60. 0 head is 24 over 60. And this one is the calculation, the subtraction one, that is 26. Now let's look at this particular question. Now this question is kind of tricky. The question says, Harry has 2 other coins, each of which is biased so that the probability of obtaining a head when it is thrown is P. So now there are 2 new coins. So this is 2 new coins. Probability of getting a head is P. Probability of not getting a head, which is a tail, is 1 minus P. Now keep this in mind. There were already 3 coins. So this is based upon 3 coins, and these 2 probabilities will be used up. So this is 3 coins and this is 0 heads. X is the number of heads. This is 0 heads and this is 3 heads. Now what are they asking? They are asking that he throws all 5 coins at the same time. The random variable y is the number of heads that he obtained. Probability y is equals to 0. That means 0 heads. So this is 3 0 heads. And then this is new, 1 head, 2 head. So 24 over 60, that is from here, that is for 3 coins, 0 heads, and then 1 minus P, that is what you get for all 5 coins. So this is for 5 coins now. And then it says y is equals to 5. So what is y is equals to 5? Y is equals to 5 is about 5 heads. For 3 heads, this is the value. And then we have heads and heads, that's right over here. So now again, this is for 5 coins. I hope this is clear. So basically, you're using the previous result for 3 coins. And this is 3 heads, and then a 4th head, and then a 5th head. So now these 2 are equal in the sense one is being multiplied with 6. So we will take this thing, 24 over 60, 1 minus P, 1 minus P. 24 over 60, 1 minus P whole square. This is 1 over 60 into P, which is P squared. The 6 is part of the equation. The denominator cancels out. The rest is all quadratics of P1. You solve, you get 2 value. P cannot be 2. Probability lies between 0 and 1. And yes, 1 and 0 can be inclusive. P comes out to be 2/3. So that's the working for this one. Now comes the last question, and that is nothing else but permutation combination. Now the question says the 8 digits 1, 2, 2, 3, 4, 4, 4, 5 are arranged in a line. How many different arrangements are there of these 8 digits? 8 factorial, because there are 8 of them, divided by 2 factorial for the 2 2s, 3 factorial for the 3 4s. This answer is simple. Find the number of different arrangements of 8 digits in which there is a 2 at the beginning, a 2 at the end. So 2 is fixed, and the 3 4s are not all together. Not all together means maybe 2 4s are together, 1 is separate. Maybe all 3 are separate. So, I mean, we don't know exactly what we are talking about. What the examiner is asking is that we cannot use separated. We cannot use the concept of spaces because this is not separated. That is not next to each other. So therefore that is separated. That is the space concept that we have talked about. But over here, the easiest way is that without any restriction, this is fixed, nothing to write. This is 6 factorial divided by 3 factorial for the 4s. This comes out to be 120 ways. Now the 3 4s are together. So put them in a box, that is 1 unit, 1, 2, 3, 4, that is 4 factorial. What is happening inside the box? Nothing. There are 3 alphabets, 3 factorial, all 3 are identical, nothing is happening inside the box. This comes out to be 24. The difference is what we are looking for, not all together. 2 4s could be together and 1 4 is separate, or maybe all 4s are separate. We don't know. That is why what we do, no restriction, minus together will give us not all next to each other. So now this one, 3 digits are selected at random from the 8 digits. Find the probability the 3 digits are all different. Now they have done in many different ways. I mean, you can just have a look at the mark scheme. I mean, you will get all bogged down and you will have a mental blockage. Let me do it the easy way. When we talk about probability, even if they are identical, we will treat it the normal way. So remember, normal way, when we talk about probability, even if they are identical, and there is one video, I think it's about the word tomorrow. Do search in my channel. I have explained that in this manner. It was about some example of some $100 bill that I talked about. Very basic idea. Just go over that. So there are 2 2s over here. There are 3 4s over here. There is 1 3 5. You separate it out. Find the probability all 3 digits are different. First scenario, don't choose, choose these 3. So 2C0, 3C0, 3C3, that comes out to be one way. Don't choose any of the 2s, choose one of these 4 and choose 2 out of these 3. 2C0, 3C1, 3C2. Do not choose the 4, choose 1, 2, choose 2 of them. 2C1, 3C0, 3C2, that answer is 6. And last option, choose one of each, 2C1, 3C1, 3C1, that's 18. Altogether, it's 34. Without any restriction is 56. Probability is 34 over 56, 17 over 28. I'll stop over here. If someone is too interested in decimals, they can give the answer in decimals, but make sure it's given correct to 3 significant figures. So that's where I'll stop. And this is the lecture on May-June 2024 S1, the first variant, which is 51. Stay tuned for more. Take care everyone and good luck with your exams.